Hello friends, this is Prasad Rajkushwaha. Today I am here with a new topic, Newmark's influence chart. So let us talk about this Newmark's influence chart. Newmark's influence chart. It is a method consists of concentric circles drawn to scale, and each scale contributes a fraction of stress. In most charts, each square contributes 1 is to 200 or 0.005 units of stress. Now to determine the stress increase, we have to follow some steps. These are first we have to determine the depth, that is Z, where you wish to calculate the stress increase, and the second is adopt a scale of Z is equal to this AB as it is shown in the figure here. As it is shown in this figure, we have to consider Z is equals to this AB value. Now the third one is draw the footing to scale and place the point of interest over the center of the chart. Uh, then count the number of elements that falls inside the footing, and now calculate the stress increase from the formula given below. So this is the formula from which we can calculate the stress increase. Now let us look towards the construction of Newmark's influence chart. Let a uniformly loaded circular area of radius r1 be divided into 20 sectors. So this is the r1 and it is divided into 20 sectors. This is for example, this is one sector. So it is similarly divided into 20 sectors. Let Q be the load intensity and sigma z is the vertical stress at depth z below the center of area. Each sector, that is O, A1, B1, this is the sector, and this sector exerts a pressure of Qz by 20. So as it is a 20 sectors divided into 20 sectors, so the pressure of Qz will be Qz by 20. From the equation of for stress below a circular load, that is sigma z by 20 is equal to Q by 20 and under bracket 1 minus 1 by 1 plus R1 by Z whole square, and again to the power 3 by 2. Hence this is the influence value. We can calculate the influence value from this formula. Now we have to fix the arbitrary value. So for an arbitrary value, this, as we have already considered, 0.005, so at 0.005 Q will be equal to Q by 20, 1 minus in bracket 1 by 1 plus R1 by Z whole square and whole to the power 3 by 2. Let us, for example, let's say for Z is equals to 5 centimeter, R1 will be 1.35 centimeter. Hence, if a circle is drawn with radius 1.35 centimeter and divided into 20 equal sectors, each sector will exert a pressure of 0.005 Q at a depth of 5 centimeter. Let the radius of a second circle be R2, which is to be determined. Now let the annular space between two circles be divided into 20 equal parts, like A1, A2, B2, B1. So R2 has to be such that the vertical pressure at the center due to each of these area units is 0.005 Q. The total pressure due to the area units O A1 B1 and A1 A2 B2 B1 is 2 times 0.005 Q. Therefore, the vertical pressure due to O A2 B2 is given by this formula, that is R2 will be 2 centimeter for Z is equals to 5. Similarly, a third, fourth and fifth circles can be drawn till 20 as we have already considered 20 it can be calculated to n number of circles. So we can give this from this equation we can calculate for each circle. For example, for the 10th circle we have got infinity, hence the Newmark's chart is drawn. In the chart, each area unit will exert an equal vertical stress of 0.005 Q at a depth of 5 cm at the center of the diagram. Hence, an area unit of the load will exert a total pressure of 0.005 Q and at a depth of 5 cm at the center of the diagram. Now, how to use the Newmark's influence chart? A plan of loaded area is drawn on a tracing paper and placed on the chart in such a way that the point below which stress is required coincides with the center of the chart. So first we have to draw the area of the loaded area, the plan, and we have to place it on the chart so that this so that the stress required coincides with the center of the chart. The scale of plan is such that the length AB on the chart corresponds to the depth at which pressure is required. That is, let the distance AB be 5 cm. Now, if the stress is required at a depth of 5 meter, then the foundation plan should be drawn to a scale of 5 cm. That is, 5 cm is equal to 5 meter, or 1 cm is equal to 1 meter. Similarly, if the stress is required at the depth of 15 meter, then the foundation plan should be drawn to a scale of 5 cm is equal to 15 meter, or 1 cm is equal to 3 meter. Sorry. The total number of area units covered by the plan of the loaded area is counted as n, and the stress exerted by the load at the point is 0.005 Qm. Thus, Newmark's charts can be used to determine the vertical stress at any point under a uniformly loaded area of any shape. Now let us look at the application where we can use this Newmark's influence chart. Seismic analysis. Newmark's influence chart provides a simplified method for assessing the response of structure to seismic forces. By utilizing the chart, engineers can estimate the maximum displacement and acceleration responses of a structure during an earthquake. Preliminary design. The chart is often used as in the preliminary design stage of a structure to assess its response to dynamic loads, retrofitting and strengthening. Existing structures can be evaluated using Newmark's influence chart to determine if they meet the required seismic performance criteria. Now the last one is research and education. Newmark's influence chart is a valuable tool for research purposes as it provides a simplified approach to studying the behavior of structures under different dynamic loads. So thank you guys for your cooperation. Thank you.